tried to get the AI to, well, I don't know, I was trying to see what AI had to say about centrifugal force and centripetal force as it applies to the turning of the Earth at the axis near the poles. So I'll just read the back and forth that I had here. Scroll down and see. I said, how does centrifugal force exert? And AI says, this is Copilot. Oh, centrifugal force is fascinating. It's not actually a real force, more a perception. When an object moves in a circular path, like a car turning a corner or a planet orbiting a star, it feels an outward push. That's because it's trying to move in a straight line, but the central force, centripetal force, keeps pulling it toward the center. Your body senses this as an outward force, even though it's just inertia in action. Okay, there's all kinds of problems with that explanation, but I'll just finish this first. I said, which direction does the force go? The force you're feeling, often called the centrifugal force, points outward from the center of the circle, but it's not a real force. It's just your body's inertia resisting the change in direction. The real force, the centripetal force, pulls towards the center, keeping you moving in that curved path. So I feel a force pulling me outward. Physics, right? Always keeping things interesting. So it's saying that I feel a force pulling me outward, and if I got something in my hand, I let go of it, it's going to fall outward. But it's really a force pulling me inward that I'm perceiving as a force pulling me outward. I'm beginning to think centripetal force is a total bullshit story because it makes no sense. Why do things fly off of a spinning object, I asked. It says, what I was thinking, imagine you're on a merry-go-round. As it spins faster, you feel like you're being pulled outward, right? That's inertia. When something spins, objects want to continue in a straight line, but if there's nothing holding them down, like a seatbelt, they'll fly off tangentially because the outward pull you feel is actually the result of their desire to keep moving straight. It's like the universe is saying, hey, keep your hands and feet inside at all times. Keep up the curiosity. I asked it, if centripetal force pulls inward, why does water not find level between centripetal and centrifugal forces? AI says, fascinating question. When an object like a bucket of water is spun around, the centripetal force pulls the water towards the center of the circular path. However, the water's inertia causes it to want to move straight and outwards. The balance between these two effects result in the water pushing against the sides of the bucket, staying at a level relative to the spinning motion rather than settling down flat. It's a real-world demonstration of the tug-of-war between centripetal force and the apparent centrifugal force. Keep those brains gears turning. I asked, response, if spun fast enough, would the water move up the sides of the bucket? Absolutely. If you spin a bucket of water fast enough, the water gets pushed up the sides due to its inertia wanting to travel straight outward, while the bucket's centripetal force pulls it in. It's the same principle that keeps the water in the bucket. If you spin it overhead, the outward force balances out gravity's pull, preventing it from spilling. Quite a neat trick of physics. There's problems with all of this. So my response was, you said the water didn't remain flat at the bottom of the bucket. How far can it move up the sides? It can actually climb pretty high depending on how fast you spin the bucket. The faster the spin, the higher the water moves as it fights to stay on its straight line path. It's wild to think that if you spin fast enough, the water can almost defy gravity, sticking more to the sides than the bottom. Physics, am I right? a little swirly thing there. What is the force direction vector predicted between gravity and centrifugal force at the polar axis of rotation? Now, that's a pretty straightforward question. The answer was, at the poles of a rotating object like Earth, centrifugal force is practically non-existent because you're not moving in a circular path, you're just spinning in place. So at the poles, the force vector is dominated by gravity, which points straight down towards the center of the Earth. It's a rare spot where you don't get that outward push from rotation. Just the good old pull of gravity holding you steady. Cool, huh? So I ask, what opposes the minute centrifugal force felt just slightly off axis? The answer, just slightly off axis, gravity is still the major player here. However, the Earth's slight bulge at the equator means that centrifugal force increases as you move towards the equator. That's a lie. The actual should be centrifugal force increases as you move away from the line of axis, not move towards the equator. So there's AI trying to lie. Opposing gravity ever so slightly. But at any point not on the equator, gravity pretty much wins the battle hands down, pinning you to the Earth. So it's saying that a bulge happens in the Earth, billions of tons of water and rock and whatever, everything the Earth is made out of. Bulges moves a little bit and bulges out, but just a little bit, and then gravity stops it somehow. So I switched up a little. Oh, it says, has this ever piqued your curiosity while you're spinning around on a big blue marble? Question? I don't know. Why are there no tides on landlocked lakes? AI says, unlike oceans, lakes are typically too small to experience significant tides caused by the gravitational pull of the moon and the sun. I know the sun's gravity was attributed to tides as well. Apparently it is. For the tides to form, a body of water needs to have a substantial area where the gravitational effects can build up. Most lakes simply don't have the size or volume to feel these forces in a noticeable way. Instead, other factors like wind, atmospheric pressure changes, and inflow or outflow from rivers affect the lake level. So you could say lakes have their own unique rhythms. Nature has its quirks, huh? And then I said, Lake Superior has sufficient mass, yet no tides. And AI says, you're right. Lake Superior does have a massive size, but it's still not quite like the ocean. Tides do technically exist there, but they're incredibly small, often less than 2 inches. You could tell the difference between a 2-inch tide and a wind blowing. Because of its smaller size compared to oceans, the gravitational forces exerted by the moon and sun don't create significant tides. We know that, on the globe, the scale of the depth of the ocean as compared to the size of the Earth is like it's like the atmosphere, or it's like a thin skin on the surface. So it's no different than a lake, really, if you ask me. Wind and atmospheric pressure changes can have more noticeable effect on Lake Superior's water levels. So while it has a mass, it's all about scale when it comes to noticeable tidal effects. Nature sure keeps things interesting, doesn't it? Then I said, well, the lake should experience tides of a lesser scale proportionally, right? Spot on, it says. Even though Lake Superior is vast, its tides are proportional to its size, but still smaller than what you'd find in an ocean. The moon's gravitational pull has less of an effect on the lake's water mass compared to the massive volume of the ocean. So, while there are tides, they're just tiny compared to what you'd experience along the coast. What about areas where the ocean is not very deep for, hundreds of miles? It still has a tide. The lakes are deeper than that, and they don't. You see, there's a big problem there. Okay, what happened to all the air changes? I gave up on that line of questioning because obviously Copilot was evading me. So I changed it up. What happened to all the airships owned by the U.S. Army and the Navy? And the answer was, the U.S. Army and Navy used airships primarily for patrol and reconnaissance missions, especially during the early to mid-20th century. However, after World War II, the use of airships declined significantly. The advent of more advanced aircraft and changes in military strategy made airships less relevant. Many were decommissioned, scrapped, or repurposed for civilian use. It's a fascinating chapter in aviation history. Do you have a particular interest in airships? Why would you scrap something? Why? How would you ever not think that it was beneficial to have some sort of flying craft that could sit silently at whatever altitude you wanted it to and not use fuel? I mean, in what world is that not something that you would, take advantage of? So I changed it up again. I didn't feel like trying to, do that one. I says, does hydrogen explode? Yes, hydrogen can be highly explosive when mixed with air. It's extremely flammable and can form explosive mixtures with oxygen. This property was one of the reasons hydrogen-filled airships became less common after the infamous Hindenburg disaster, where the hydrogen-filled airship caught fire and was destroyed. A little spark can set off hydrogen gas, making it a powerful yet dangerous element to handle. Chemistry, right? Always a blast, sometimes literally. So I tried to get a little more specific. Does hydrogen implode? Hydrogen doesn't naturally implode, but it can be compressed. While implosion refers to collapsing inward, hydrogen is usually associated with explosive reactions when combined with oxygen. Under high pressure, liquid hydrogen can be stored compactly like in rockets, but it's those explosive tendencies that are more well known. Pretty wild stuff. Any other burning questions or perhaps a more stable topic? I don't even understand the answer it was trying to give me there particularly. Hydrogen, when it's ignited, it reduces its mass, and the byproduct, excuse me, is water. So, it implode. They're trying to say, oh no, it's explosive, and the explosion creates water vapor, and then the water has less mass. The hydrogen doesn't implode. The water that it turns into after burning has less mass, and that's not an implosion. That's something different. Semantics right there. So I ask, what happens to the mass of hydrogen and oxygen when ignited? When hydrogen and oxygen ignite, they undergo a chemical reaction known as combustion, forming water. The total mass of the hydrogen and oxygen before the reaction is equal to the total mass of water produced. This is due to the law of conservation of mass, which states that matter cannot be created or destroyed in a chemical reaction. So while the hydrogen and oxygen transform into different substances, their combined mass remains constant. It seems like it should address the reduction in size as is relative to implosion. Is the mass proportional to its volume? I ask. Answer. The relationship between mass and volume is defined by density, which is mass per unit volume. In the case of water, when hydrogen and oxygen combine, the water formed has a consistent density of about 1 gram per cubic centimeter at room temperature. So yes, the mass of the water is proportional to its volume according to the density. Chemistry and physics working together, huh? Want to dive deeper into this or something else? So I ask, I'm almost done here. Can combustion of hydrogen and oxygen create a vacuum? Because, you ignite them inside of a container and they reduce their mass and leave a void. Combustion of hydrogen and oxygen produces water in the form of vapor. If this vapor is then cooled and condenses into liquid water, it significantly reduces the gas volume, potentially creating a partial vacuum. So while combustion itself doesn't create a vacuum, the process of cooling the resultant vapor can lead to a significant drop in pressure. Fascinating how chemistry can play tricks like that. I mean, if it creates a drop in pressure. So the mass can be said to implode its volume as it recombines into H2O. That's what I stated afterwards. And it says exactly. Thought it didn't implode, right? Exactly. When hydrogen and oxygen gases combine and form water, the resulting liquid takes up significantly less volume than the gases. This dramatic reduction in volume as gas molecules condense into liquid can indeed feel like an implosion, pulling the mass into a much smaller space. Chemistry does have its moments of magic, doesn't it? What other wonders are you curious about? Expansion is an effect of pressure? Question mark, I said. Yes, expansion is closely tied to pressure, especially in gases. When you increase the pressure on a gas, its volume decreases, and when you reduce the pressure, the gas expands, occupying more space. This is encapsulated in Boyle's law, which states that the pressure and volume of a gas are inversely proportional, assuming temperature is constant. A neat interplay of forces at work. So I asked, what drives the expansion of the universe if it contains a vacuum? AI says, excellent question. The expansion of the universe is primarily driven by a mysterious force called dark energy. I think that's where I finally got AI to lie to me. It's speculating about things that are not real, right? What drives the expansion of the universe if it contains a vacuum? Dark energy, AI, Copilot says. Despite the vacuum in space, dark energy works against the pull of gravity, causing the universe to expand at an accelerated rate. Think of it like an unseen force that stretches the very fabric of space itself. Truly mind-blowing stuff, literally and figuratively. What fascinates you more, dark energy or dark matter? Which was kind of asking me to pick one. My response to that was, I don't think that can be proven in any real way. And AI's reply was, dark energy and dark matter are still largely mysteries in the scientific world, and while there's strong evidence to support their existence, like the accelerated expansion of the universe or the way galaxies rotate, it's true that much of it remains unproven. This is what makes the field so fascinating. We're constantly on the edge of discovery, challenging our understanding of the cosmos. What other uncharted territories tickle your fancy? So I think I was successful in getting AI to basically lie to me. I mean, to invoke dark matter as an explanation, and then the only examples it can give are, space and galaxies. I mean, the universe expansion, that's just ridiculous. Ridiculous. So, I don't know, did I get AI to lie to me? I mean, it was obviously evading my questions all through this whole thing when I started out, from beginning to end, even when I changed topics. It's trying to portray things in the proper way, but I don't know. What say ye?